Assalamu alaikum dear viewers, Shoaib and Dayo is here with a new experiment of the DC motors, and today we are going to perform the experiment of the DC shunt wound motor. Before performing this experiment, we need to know the working principle of the DC motor. A DC motor is a device or machine which is used to convert the DC electrical power into the mechanical energy or mechanical power. So that will be called the DC motor. So its working principle is totally depend upon the whenever a current carrying wire or a conductor placed in a uniform magnetic field, it experiences a mechanical force. That mechanical force produces the driving torque in the shaft of the DC motor. So this was the fundamental definition of the DC motors, that it converts the electrical energy into the mechanical energy. Now we are talking about the operation of the DC motor. The armature of the DC motor is energized from the DC supply, and hence the induced currents are being produced in the armature conductors. And the sum, because our armature conductors are the group of the conductors, so sum of all the mechanical forces which are to be add together and experiences a mechanical force, and that mechanical force produces the driving torque of the DC motor. So this was the operation of that DC motor. Now another thing in the DC motor is that in the generator, in the previous experiment we have analyzed the output terminal voltage of the DC generator, but now here we are giving the electrical supply to the DC motor. So in the generator we were obtaining the generated EMF, and here we are obtaining the back EMF in the DC motor. So we have to discuss about the back EMF concept regarding in the DC motor. What is the back EMF? When you are given the applied voltage to the armature conductors, what happened according to the Lenz's law? The direction of the induced EMF is opposite that cause which is given to produce it. Now here, what is the cause? The cause is that the armature voltage. The cause is that the supply voltage, and the voltage which is induced in the armature conductor. So that voltage is called the counter EMF or the back EMF, which is produced in the armature terminals, and that back EMF is totally opposite to that applied voltage. Today in this experiment we have to verify the operation of the DC shunt wound motor, and also we have to verify or to read the significance of the back EMF which is to be produced in the armature terminals of the DC motor. And also, before starting this experiment, we have to connect the starting resistance with the armature terminals of the DC motor. Why we are connecting the starting resistance? What happened when the motor is in the stationary position? There is no back EMF in the motor, and starting condition for the to limit the starting current, if you are not inserting a resistance. For example, this is the resistance. If it is not inserted in series with your armature terminals, what happened? The current will drawn from the supply is too much maximum. Obviously, if there will be the too much maximum, maybe it may cause the burning of the armature terminals in that DC motor. So what happened? We need to connect the starting resistance in the motor with the motor to limit the amount of the starting currents. And what happened? The mechanical forces are being experienced in the armature conductors, and the driving torque is produced. Now, before conducting this experiment, we need to know the circuit diagram of the DC shunt motor. Okay. In the DC shunt motor diagram, you can see the supply is given to the armature terminals, and here the field winding is connected in parallel across the armature winding. What happened? The shunt field winding has the greater number of the turns with the thin wire, and also the armature conductor, this is the armature conductor, and the supply is given to that armature conductor. And so this is the type of the DC shunt wound motor, because the armature winding and the field winding both are connected to parallelly to each other. Now we have to pull out all the wires, and we have to perform the experiment, and we need to observe the parameters like the voltage which is induced in the armature. That voltage already I have explained in this experiment is called the armature voltage or the back EMF, and we have to give the supply. First of all, we need to give the supply to this armature. So this is the DC supply, and before going to connect this supply to the armature terminals, obviously you need to measure the current of the armature with the help of the ammeter, which is connected in series with your supply voltage, and that ammeter is connected in series with the armature resistance to obviously to limit the starting current, and that starting current, if it is going to be limited, the motor will run, inshallah. So this will be connected in series with the ammeter and the armature resistance with the armature winding. So if it is a shunt motor, obviously you need to connect the parallelly both windings. Okay, and this negative terminal is connected with this supply negative terminal. Okay, and now you need to measure the shunt field current over here. Okay, and this one is the shunt field current. Now you need to measure the armature voltage, okay, which can give us the reading of the back EMF. So this voltmeter will give us the armature voltage or the back EMF in the DC motor. So we have connect all the modules with this DC generator, shunt mode generator. Now run the generator. As you can see, this is a field current 0.26 ampere from the ammeter, which is connected in series with the field winding, and this is the ammeter which is connected in series with the armature winding. Obviously this will give us the armature current 0.48, and this is the voltage which is produced in the armature terminals. So this voltage is called the back EMF or the counter EMF in the DC motor. Okay, so this is the starting resistor which is connected in series. I already explained that before starting the DC motor, you need to connect the starting resistance in series with the armature. So if you are not, what happens? The motor cannot run, as you can see. So you need to limit the starting current by inserting the variable resistance or fixed resistance to limit the starting current of the DC motor, so that you can, if you are limiting the starting current, obviously the motor will produce the sufficient amount of the torque and it will rotate in the direction of the magnetic field. So this was the experiment of the DC shunt motor, in which we have understand the operation of the shunt motor, and also we have understand the circuit diagram, and even that was implemented on this trainer with the different modules. And at the last, we have already know from this experiment that significance of the back EMF and the counter EMF which is produced in the armature terminal. So this was the experiment. I hope that you have understand today's experiment regarding the DC shunt motor. And at the last, please don't forget to subscribe my YouTube channel Shoaib, because your subscription and your liking and your sharing my link of the channel to your fellows, your colleagues, gives me more motivation to make more content related to the electrical engineering area. Thank you very much.